Good day, Mrs. Alberts. The following fingerprinting experiment presentation was put together by the members of Team 82 of Lecture Group 10 and will go along with the research topic of classifying fingerprints according to their distinct pattern types.
The main purpose of this experiment was to make record of randomly sampled fingerprints in the hopes of classifying them into their distinct categories and to determine whether fingerprints can be classified under one of the 8 fingerprint patterns found in Annexure A. Classifying fingerprints into their types makes it easier for certain institutions to store information in a database. Such information can then later be used for crime scene investigations, biometrics, as well as forensic sciences. The experiment was carried out using common everyday items such as baking powder, sellotape, and paper. The fingerprints were recorded by marking a piece of sellotape with the fingerprint coated in that baking powder, and then later recorded and compared to those fingerprints of Annexure A. Of our 4 fingerprints examined, person 1 and person 4 had a radial loop classification, whilst person 2 and 3 displayed ulnar loops. It was evident that all 4 of the randomly sampled fingerprints indeed could be classified under one of the 8 types of fingerprint categories. Therefore, fingerprints can easily be logged onto a database according to their distinct fingerprint pattern categories. A way to improve this experiment would be to investigate the role of genetics in the formulation of fingerprints and whether certain fingerprint types are inheritable or exclusively unique to every individual, regardless of any individual's genetic makeup. Another alternative of the experiment would be to investigate whether a certain fingerprint pattern is predictive of one's personality trait.
The experiment will be conducted as follows. Fingerprints of 5 randomly selected individuals will be collected with strict adherence to the methodology below. The collected fingerprints will then be analyzed and classified under one of the 8 fingerprint pattern types. By classifying the fingerprint samples, we reduce the amount of work that goes into discovering the identity of one's fingerprints. As fingerprints are submitted to a database under strict classifications, the search for the identity behind the fingerprint becomes simplified. Such an experiment can help the youth engage in activities which are related to the forensic sciences. This is mostly beneficial for those who are keen to pursue a career in forensic science and would like to get a glimpse of what the career path has to offer.
Apparatus: clear sellotape, fine dust or powder, a paintbrush, a black sheet of cardboard paper, and a pair of scissors. Method: Step 1. Dab one of your fingertips into any fine dust or powder such as baking flour, maize meal, or baking soda. Step 2. Use a paintbrush to lightly brush off any extra powder on your fingertip so that a very thin layer forms on your finger. Step 3. Cut off a piece of tape that will cover the entirety of your chosen fingertip and put it to the side for later use. Step 4. Carefully place the sellotape over your fingertip that is coated in powder without smudging the fingertip. Then, carefully lift the sellotape away. Step 5. Take the piece of sellotape and carefully place it onto the sheet of black cardboard paper and make sure not to try and smooth the piece of sellotape out. Step 6. Repeat all the steps from step 1 to step 5, this time using each of your other 5 fingers on your hand, and do this for each hand. All done.
The results. Fingerprint sample person 1. Its corresponding finger pattern was radial loop. Person 2. Its corresponding finger pattern was ulnar loop. Person 3. Its corresponding finger pattern was also ulnar loop. Person 4. Its corresponding fingerprint pattern was a radial loop. The discussions. All the samples show similar fingerprints, but the difference lies in the direction that the fingerprints swirl. We were hence able to easily see the pattern of each sample and classify each of the fingerprints. One major problem that occurred was getting the layer of flour to evenly spread over the thumb without causing any clumps. These clumps made it difficult to read the pattern represented in the fingerprint samples, which can be seen in the sample from person 4. A solution to this problem will be able to use a powder that is less likely to clump like cornstarch or maize meal.
From this experiment, we can gather that fingerprints can be classified into distinct groups based on their shapes. Although fingerprints differ from one person to the next, fingerprints follow a generic shape or structure with small yet noticeable differences. Such information can therefore be inserted into a database and used by selective institutions such as governments and forensic companies.
Using baking powder for this experiment was appropriate. However, too much powder blurs the results. We recommend that you do not apply too much powder on your fingers. Some fingerprints were not visible enough. We overcame this by using fluorescent light, which make the fingerprints more visible.
One way to improve this experiment would be to investigate the role that genetics plays in the formation of fingerprints. That would be a test to determine whether the fingerprint pattern type 1 has is influenced by the heredity of a certain gene. In other words, testing whether a certain gene is responsible for the patterning of a fingerprint. Another approach to develop this research topic would be to link certain fingerprint patterns to personality traits. This could help establish whether certain fingerprints have predictive features of one's personality. This could be done by looking for similarities in personality among people characterized under the same fingerprint pattern. The image shown represents the reference point used to classify the fingerprint samples gathered.